Hey, what's going on, everybody? This is your boy Algebra, recording this new video for the inverse matrix solution method. Recorded one for you earlier, put it on YouTube, but the sound quality was a little bit messed up. So we're going to redo this one real quick. Should take about 5 to 7 minutes. I'm going to explain how to solve an equation that looks like this, as well as a system of equations for you. The notes are already on Blackboard. So are your study guide notes and everything else that you need to see in preparation for tomorrow's test. Those of you who went on the Model UN trip, you guys are all taking it on Wednesday. And then we can also have our little study session after school tomorrow for the 6 of you. Last thing I need to remind you is I will be putting up another video, probably not until I get home in a couple of hours, about how to use your calculator effectively in solving these matrix solutions, as well as to find the inverse and the determinant on your calculator one more time before the test. But the big thing for today is making sure that you understand how to do the inverse matrix solution. Having said that, this is the equation that we're going to be using. It has a 2 by 2 matrix, 6, 3, 5, 2, multiplied by some unknown matrix, and that has to equal the 2 by 3 matrix on the other side of the equal sign, which is 2, 3, 1, 5, 0, 6. First thing I need you to do is understand this concept. If you want to get rid of a matrix, the first thing that you need to do is find its inverse. Just like any other time that we are trying to cancel something out, using its inverse is a really good idea. When we define the term inverse, we use this expression, or excuse me, this equation. It said that A times the inverse of A gives you the identity. In other words, if you multiply a matrix times its inverse, it cancels it out. And so the first thing I need you to do is find the inverse of that first matrix. 1 over the determinant, flip going down, negate going up. This is what you end up with. So I'm going to be taking this inverse matrix over here and using it to cancel out the original matrix on the left-hand side. So magically appearing on the screen right now, you see these 2 yellow lines showing you exactly where I'm going to be inserting this extra matrix. By doing this extra matrix information, I'm going to be able to cancel out the first one, leaving me with just my answer is equal to the multiplication of 2 matrices, which of course you do know how to do. So I'm going to pause the screen, go ahead and move this stuff around so you don't hear it, everything clicking on the screen like in videos past. But you're going to see an expression on the left side that will cancel out 2 matrices, but then on the right side of the equal sign you will have a matrix multiplication problem. Again, you know how to do that. Alright, so again, by inserting this matrix to the front, you're going to be able to cancel out the entire side except for that x. On the other side of the equation, you're going to have a 2 by 2 times a 2 by 3. And obviously with a 2 by 2 and a 2 by 3, the inner dimensions are matching. So this is a multiplication problem that you can handle. Just to remind you in preparation for your test again, making sure that you understand that a 2 by 2 times a 2 by 3 is going to give you a result that is a 2 by 3. So I'm going to go ahead and pause the screen again, go ahead and write out the multiplication so it pops up magically when I start to record again. I'm also going to be getting rid of the inverse calculation down here below, and our final result is just going to be a 2 by 3 matrix that results from a 2 by 2 times a 2 by 3. Alright, so obviously from this multiplication down here, you can see that you end up with a 2 by 3 matrix, just like what we wanted originally, and this matrix is representative of the x. So not only could you solve for individual elements, but you can also solve for an entire matrix using this matrix inverse solution method. So please make sure that you understand this moving forward. If you want to cancel out a matrix, you can just multiply that entire matrix by its inverse. So again, I'm going to pause this video so that you can take a look at the screen. I'm going to magically reappear with the next problem set and then walk you through how to solve a system of equations using this method. Hey! Guess who's back, y'all? So what I did is I set up a system of equations while you were gone, just two variables this time because I don't want to overwhelm your brains at this point in the evening. Hopefully you're all getting a chance to check this out and also to check out everything that has been uploaded to Blackboard since the beginning of the day. Everything from the entire chapter is uploaded, study guide, answers, the previous video that was recorded with poor sound quality, as AK-47 told me earlier today. So now I'm going to do a system of equations problem using the inverse matrix solution method as well. You will be asked to either do this or the Gauss-Jordan method, so hopefully those of you in my first period class tomorrow are actually checking your email and watching the video as you were told to do via email. You guys understand this. You are required to know this. So you need to spread the word just in case one of your classmates did not watch the video themselves. Having said all that, setting up a coefficient matrix for you on here. I'm going to start off with a 3, 5, 7, -2. Now what this does is very similar to the Cramer's rule. You are going to be able to use a matrix to help you solve the system. The major difference is, instead of setting up all these different matrices, I'm really just going to have two. And in these two matrices, the first one is all the coefficients, and the second one is going to be just the answers. Now, when I talked about the Gauss-Jordan method last week during class, we were augmenting the matrix. This time, the difference is I'm using matrix multiplication to actually find out what's happening. So I have a coefficient matrix, I have an answer matrix, and between the two of them, that's where I'm going to actually figure out what my x and y are equal to. Set up the same way as that last problem that we did, we need to find the inverse. So magically appearing right here on the screen in this pink colored font is your inverse matrix. Again, the reason why you're doing this is because it cancels out completely over here on the left hand side. On the right hand side, all you have left is a simple matrix multiplication problem, which, albeit with fractions, you guys are very capable of handling, and your answers are going to be in the same shape as your XY matrix. The matrix XY in this particular problem is equal to the matrix that would say 2, -2. You can go ahead and do the multiplication yourself. It does work out. But this system of equations, instead of using substitution, instead of using elimination, instead of listening to Gauss-Jordan, or instead of even going through Cramer's rule, can be solved in a fifth different way now using the inverse matrix solution method. Notes for this are on Blackboard. All the notes for the rest of the chapter are on Blackboard. Homework solutions are on Blackboard. Study guide and its solutions are on Blackboard. Even a checklist of the things that you need to be able to do with and without a calculator can be found on Blackboard. So about 10 minutes into this video, this is your boy Algebra signing off. Peace.